Hello. The purpose of this video is try to help you understand how better to use your calculator. I have 5 calculators which I'm going to look at. I'm not going to do everything on all of them, but I will at least get you pointed in the right direction on all of them. So the first thing I want to do is show you some basic manipulations, and to do that I'm going to show you my TI 83 graphing calculator here. So first off, let's clear it. You should check whether you're in degrees or radians. The easiest way to do that, if you don't want to access menus, is hit sine of 30. That should give you a value of 1/2 as shown here. If it gives you something that looks like -0.9, you're in radians. To switch that, on this calculator, you hit mode, and down here on the third line, you can switch between degrees and radians. On the top line, you can move between normal, scientific, and engineering notation, which you may want to do for this class. If we look at the other calculators, here is a really basic calculator. This one has a DRG button to switch between degrees, radians, and the third one is gradients. I've never used gradient. I could not, on this calculator, determine how to switch between normal notation and scientific notation. Next calculator is a Casio. It also has, no it does not. This is the one that has a weird menu system that I'd never seen before. So you can see up here at the top, it gives you lots of options. So if I hit mode 4, it'll make sure I'm in degrees. If I hit mode 5, it'll switch me to radians. And then mode 7 and 8 switch me between normal and, or mode, looks like maybe mode 8 and 9 switch me to normal and scientific notation. Here is a TI 30XA Solar. I have a DRG button again, and down here over 4 and 5 I can switch between normal and scientific notation. And lastly, I have a TI 30XS, and if I turn it on and go to mode, again I have the option between degrees and radians and normal and scientific. Next, I want to show you 2 calculations, one involving scientific notation, one that's just a more involved denominator and how you have to enter things when you have that. So for that, we're going to do the scientific one first. And I'm going to begin by showing you this on my graphing calculator. So here we are on the graphing calculator again. Clear it off. Okay, every calculator has some sort of button which tells the calculator, hey, I'm meaning for this to be scientific notation. So you might expect, because it looks like scientific notation, to use the 10 to the x button, which is located above the log. That is not the button you want. Instead, what you want is this EE. So to access it, I have to hit second. So if I want to enter the first number in that calculation, 6.67 second EE, -11. The calculator realizes this is one number, it's in scientific notation, and it has a value of 6.67 times 10 to the -11. Okay, so now finishing this calculation off, 24th times 1. Okay, so there's the numerator. Now I could have put parentheses around this and then did the division. But I really want the value of the numerator for comparison in the future, which is 7.92 times 10 to the 44. I'm now going to divide by the denominator, 151.26 times 10 to the 9. Now, because the calculator recognizes that as all one number, I can just square it. Contrast that if I did this. Okay, so there's my numerator back. Okay. So now it looks reasonable, but when I enter it, it doesn't like it at all because it's too big. That's what that overflow meant. Okay, but it wouldn't have given me the number the correct number anyway, because what this is going to do is it's going to take my 792 times 10 to the 44th, divide by 151.26, and then multiply all that by 10 to the 9th squared. Okay. This calculator has a quirk to it, and that quirk is that you have to get out of the exponent. Oh, the button you want on this calculator is the times 10 to the n button in order to do scientific notation. So if I add 6.67 times 10 to the negative 11, now in order to tell this that, hey, I'm done with the number, I've got to hit the arrow over button, and now I can just keep entering. Oops, see, I forgot the arrow over button, so now on this one, you also need to put the denominator in parentheses because of how it works. If you don't do parentheses, then it will only square the 10 to the 9th again. Right, so 3.46 times 10 to the 22, which is the number on the PowerPoint slide. And you can see that it's still a TI. It's the same brand of calculator, but the way it's manipulated and the way it's used is very different. So it's very important for you to know how to use your calculator for this class. The TI-30XA Solar has an EE button again, so I can enter the values in the same way I did on my graphing calculator. On this little Casio, it doesn't have a EE button. What it has is an EXP button down here at the bottom. Okay. So using it, plugging things in, notice on the display it also doesn't give you a capital E. All it tells you is 6.67, and that looks like it's raising that to the negative 11, but this is the way this calculator shows scientific notation. So continuing to input 24 times 1.99, 30. There's our numerator, and I need to use parentheses on the denominator. And that gave me the correct answer. This final calculator also has an EXP button, and I would enter the math in the same way as I did on the previous button. Okay, the second slide I'm going to show you is a percent difference calculation. This is something that you will encounter more in lab than in lecture, but it's still a good example for when you need parentheses and when you don't. Notice the numerator here is absolute valued, and there is somewhere in this calculator an absolute value function, but we can change a minus sign to a plus sign at the very end in our head, so I'm going to ignore that. If I enter this formula just as it is, ignoring parentheses, I'm not going to get the correct number. I get 338.3, which is vastly different from 2.82. And the reason for that is because of order of operations. What it's doing is it's taking 3.5 and then subtracting the quantity 3.6 divided by 0.5 times 3.5, and then adding to all of that 3.6 times 100. Okay, not what we're wanting to do. So to get this correct, if I want to enter it all at once, I need parentheses. So 3.5 minus 3.6, parentheses around my numerator, divided by 0.5 times, we need two sets of parentheses in the denominator, and then I can multiply everything by 100 at the end, and then I get the 2.82 with the negative sign, which I expected. Absolute value is 2.82. If I want to enter this on any of the other calculators, I have to do the exact same thing. I have to use all those parentheses. Okay, on this calculator, I would have to use the same parentheses as I did on the previous one. So 3.5 minus 3.6, negative 0.1, that makes sense. Divide by, we need a parenthesis, 0.5, times another parenthesis, 3.5 plus 3.6. Close that parenthesis, hit equal. There's my 0.028, but remember I still need to multiply by 100. So there's my 2.82%. And all the other calculators are going to work similarly. The biggest errors I see students doing with these calculations is forgetting parentheses and not knowing how to properly enter scientific notation, which is why I tried to address those two pieces. If you have difficulty with your calculator and just cannot input things and get things correct, email me and we will Zoom and you can show me what you're doing and I will try to help you correct whatever error you're making. Thank you.